Tech Talk Tuesday.
Hey, this is Will with SRT Amplification, and this week is going to be an early episode of Tech Talk Tuesday. I've got some family coming in this week, and I'm going to get this out a little bit early, so you'll probably see it on Monday instead of Tuesday. But today I wanted to talk a little bit about capacitors and markings on capacitors and the values of capacitors and how that translates to what you see in a schematic or what you see inside of an actual circuit, and then what's actually marked on a capacitor. So one of the things that I've noticed that a lot of people struggle with is how to convert between, microfarads, picofarads, all the different prefixes in the metric system, and then actually what they're actually seeing on the schematic. So I've got a few tips I'm going to share with you on how I do it, and if it helps you out, then that's great. If it doesn't, if you got a different way of doing it, please let me know in the comments, and we'll share it with everybody. But this is the way I do it, and it seems to be kind of a simple and a way to keep it straight in my head anyway, and maybe to help you guys too. So let's look at some of these things. One of the first things that we have to look at and to kind of familiarize ourselves with is how we come up with the different prefixes for the values that we're talking about, whether we're talking about henries or ohms or farads or amps or whatever. Basically, in the metric system, everything is based off of 10. It's a base 10 system. So you have exponents of 10, whether it's 10 to the first power, 10 to the negative first power, whatever. Basically, that number that is the exponent is how many zeros forward or backward the decimal point's going to go, or how many spaces the decimal point's going to go. So when we're talking about farads is a value of capacitance, and it's a very small value. So your typical capacitance values are going to be usually in at least the micro range, and more than likely, a lot of them are going to be down in the pico range, which is if you could look at this chart here, the micro is 10 to the negative 6. So that means basically if we start at 1 and we go down towards, so if we start at 1 right here, what would be 1, and we count back 6 spaces, that's where our decimal lines. Or you could look at it like this: if you count 6 spaces this way, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, we'll wind back up at 1. So it's 1/millionth basically of 1. So that's why the 6 decimal places. Pico, on the other hand, is 1/trillionth, or 10 to the negative 12th. Or another way of looking at that is 1/millionth. And you'll actually see some values either on schematics, or I've even seen it on capacitors themselves, that'll say micro, which would be the same as 1/millionth. So if you can wrap your head around this, basically what you're going to be doing is working between micro and pico, because that's where the values are going to be on most capacitors. So what you need to do is realize that there's a 6 decimal place difference between micro and pico. So if somebody says that I have 1 pico farad, which would be out here, all I need to know is I need to go 6 spaces this way, 1, 2, 3, 4, 5, 6, and it would be 0.000001 microfarad. So I'm basically just moving 6 decimal places. Hardly ever do you see nano. They do have capacitors that are in the milli range, but they're very rare too, especially working with amplifier circuits and stuff like that. You're not going to run into those too much. Alright, so let's look at some capacitors real quick, on the actual capacitors themselves. and see the markings on those.
So here we're looking at some old paper and wax style capacitors. And if you'll notice on the value, they use the abbreviation capital MFD. And at this time, this was their annotation for microfarads. I've been told that they used this because the equipment that they used at the time, we're talking, 60s, 50s, 60s, 40s, even 30s, did not have the ability to reproduce or to type or print the Greek letter mu, which we use as a symbol for micro. So in this instance, they used MFD, which is just kind of an abbreviation for microfarad. They couldn't use the lowercase m because that might be confused with a millifarad, although I've never really seen any capacitors or schematics label capacitance in millifarads. There's a possibility that it could. But if you also remember from our chart, the capital M is the prefix that we use for mega. And so I guess that they assumed that people would not confuse the big M for mega, because that would be a very, very large capacitance in a component to have. And maybe somebody's built a capacitor with that much capacitance, but if they did, it's probably not something that the consumer is going to be using. So in this instance, if you see one of these old style capacitors in any vintage gear, this MFD is microfarad. So the one on the top would be 0.1 microfarad, and the one on the bottom would be 0.05 microfarad. So let's look at a modern day capacitor. Okay, these three capacitors are modern day polypropylene foil type capacitors, used in a lot tone circuits, coupling caps, etc. They're non-electrolytic, non-polarized capacitors. For these types of capacitors, the value is kind of coded into them. And if you look at the top of each one of them, starting on the left, you have a 224K, a 683K, and a 104K. What confuses a lot of people is the K. The K is not a multiplier. It doesn't mean 1,000, anything like that. The K is actually a letter designation for the tolerance of this capacitor. K being 10% tolerance. You'll also find common J, the letter J, which is a 5% tolerance. But there's pretty much all different kinds of tolerances, and they just use letter designations for those. You have to look it up on a chart. But normally you'll find J's and K's, 5% and 10% tolerances. As for the value of these capacitors, we have to look at a chart in order to learn how they use this coding. And then once you know how the coding goes, you can just look at a capacitor and tell what the value is with a little a little manipulation. So let's look at that chart right now. A chart that gives codes, common codes for capacitors. But once you understand how this works, you really won't need to look at the chart. But just know that there is a chart you can look at if you want to reference it each time. So our first capacitor in the picture had the code of 224, and I've circled it here on the chart. Basically, the 224 is, the way I look at it, is 2 and then 4 zeros, and that is the value in picofarads. So if you look at the column circled, the far left column that's circled, you will see that it's 2 and 4 zeros, which is 220,000 picofarads. And then if you remember from our chart where we moved the decimal place over 6 times to convert to microfarads, that would give us a total of 0.22 microfarads. That 0.22 microfarads is more than likely what is going to be written on a schematic. So in order to get from 22 microfarads on a schematic and know what capacitor do you have in your bin when you find find the correct one, you would need to convert to picofarads and then look at 22 and 4 zeros, which would give you the code of 224. At least that's the way I do it. So let's see how this applies in a schematic, and I'll show you kind of how I do it when I go to size capacitors for a schematic. Commercial schematic for a Silvertone model 1484 from the 60s, and I chose this schematic for a couple of reasons. Number one, everything's pretty well legible, and number two, they use different ways that they name the capacitors, or that they label the values of the capacitors on the schematic itself. So by convention, if a capacitor just has a value on a schematic, it is assumed that it is microfarad unless otherwise annotated somewhere on the schematic, either on the value itself or somewhere else on the schematic in the corner on a legend or something like that. So let's take a look at three of these capacitors in the circuit here. The first one we're going to look at is circled in red. It's labeled as C1, and the value on it is 25 volts. So I would not even convert this capacitor at all, because this capacitor is above 1 microfarad, so that tells me that it is a electrolytic capacitor. So you know, most of the time, you know, you don't have any kind of capacitors besides electrolytic capacitors that are above 1 microfarad. So this one would be a capacitor that actually is labeled in microfarads. It won't be coded. It will actually be typed out as 25 microfarads, whether they use the mu symbol or a U or an MFD. If it's an older type of a capacitor, it will actually say 25 microfarads on it in some way. It won't be coded. So I wouldn't change this one. So this is just kind of a side note. But one thing about this schematic is they fail to use the convention of what a electrolytic capacitor symbol would be, and they fail to give you any type of polarity on this one. But just note that that is a electrolytic capacitor in that spot there, being a value of 25 microfarad. So going up to the top and looking at capacitor 3, it's got a value of 0.02. That 0.02 would be in microfarad. So when I go to find a capacitor to put in this circuit, if I'm scratch building this circuit and just using this as a template, I would go to my bin and find a 0.02 microfarad capacitor. But more than likely that capacitor, if I'm using a modern day capacitor, will not be labeled as 0.02 microfarad, and I'm going to show you how to do that in just a moment. Moving over to capacitor 8, labeled C8, we see that this one has actually got a value of 680 microfarad, or they're using the letter U instead of a Greek letter M or Greek letter mu for micro. But this is basically telling you that, if you remember from our previous chart that we looked at in the beginning, the microfarad is the same as a picofarad. So this is telling you that this capacitor is 680 picofarad. And because it's already in picofarad, I can go to my bin really easy and find exactly what capacitor is this value. And it would be one that was labeled 681. 68 and then 1, because there's 1 0 to the right of the 68. So that would be 680 picofarad. Now, what I normally do is I'll go through the whole schematic, whatever schematic I'm using, and I'll go ahead and convert everything into picofarads, and it just makes it easier for me. So if it helps you, that would, try it, and you'll find that you probably won't have to use that chart anymore. So up at the top there above the green circle, I have converted the 0.02 microfarad into picofarad and came up with 20,000 picofarad. So if you remember from our chart, you take the first two numbers, which in this case would be 20, and then the number of zeros to the right will be your next number. So in this case, I'm going to be looking for a capacitor that is labeled as 203, and I will know from that I now have a 20,000 picofarad or a 0.02 microfarad capacitor. So that's how I do it.
Okay, so I hope that cleared a little bit of confusion up for you and didn't confuse you even further. But I know we didn't talk anything about surface mount capacitors or anything like that. But some takeaways from this would be that anytime you have a modern day ceramic, polypropylene, polystyrene, any type of foil capacitor like that, you're more than likely going to run into these codes. And that's how you're going to have to determine what the actual value is based off of that. And most of the time with your electrolytics, it will actually say in microfarads what the value is, so you won't have to do any converting at all. But for the other capacitors, you will have to do some kind of converting. And I hope that by using this method, it will help you and maybe not be so confusing to you. So I appreciate your time, and I hope that this video helps those of you out there that are watching. And if you haven't hit subscribe, please do that and like this video. Again, thanks for watching, and we'll see you on the next Tech Talk Tuesday.